Morning, everyone. In the last video, we have seen that with the advanced plan simulator, we know how to evaluate the plan with seven plan complexity metrics and how to access this that open source application. And now with this plan analytics application, we can able to evaluate the plan with nearly 30 plan complexity metrics. Okay. If you go to the bottom of this page, there is a metric reference mentioned over here in this left side, left corner. Just click on that one. See, there are all the nearly 30 metrics are mentioned here. Like it's those metrics divided into four categories. Like first one is the primary complexity. So this a primary one is like modulation complexity score, leaf sequence variability, aperture area variability, and the mean field area. Okay, there is a first category. The second category is a secondary metrics. Okay, derived and aperture based metrics only, complexity metrics. That is as a leaf, start from leaf travel to the plan aperture modulation and also a plan beam aperture modulation. Moving on to the third category is that accuracy metrics. Okay, metrics related to the dosimetric accuracy. Okay, which will have a significant impact on that one. That is like mean, they start from mean asymmetric distance to and tongue and groove index. And the fourth one is the deliverability metrics. Metrics related to the treatment delivery characteristics. Okay, that is mu per control arc. Start from that leaf travel per mu and leaf speed and minimum dose rate, mean dose rate variation. It goes on up to the jaw area. Sorry, that's the third one. And that's a fourth metric. And delivery parameters like average dose rate, average emergency speed, those details are also available with this one. Okay. And there is a clear-cut technical reference mentioned on each and every metric. We can able to see clearly they mentioned that the publication and those are the technical reference we can able to see. Okay, these are the coordinate systems. And these, all the details, we can get it from the help and documentation section. Okay, sorry. And with that, there is a four analysis mode given. There is a single plan analysis mode, batch analysis, and the plan comparison. And mainly the statistical analysis. That is like quite good. This one we have multiple plans, 150 to 100 plans. It will give you a clear cut statistical analysis. It's like beautiful one. Okay, and the machine presets. They are having a preset machines from the variant TrueBeam, Alchian, Ethos, Electra Versa HD, and Electra Unity, MR linac, and Electra Harmony as well. Okay, these are the preset machines provided here. Okay, now moving on to the single plan analysis. Okay, just here in the here we have to drop the dichromatic plan. We can have to browse and drop it also. Just click on this part. Okay, now we have to selecting a one plan. Okay, once you select it, it's automatically move on to this particular window. It will give you the how many beams are there, mu, dose, and those beam parameter details will be available here. Okay, once you click this CW count clockwise and counterclockwise, two arcs are here. Okay, if you go down, scroll down, and you can able to see the visual representation of the and graphical representation of the whole plan, and dynamically how the jaw tracking is, how the jaw tracking, and with that only there is one metric we are calculating jaw area. Okay, and how the MLC apertures are moving. Okay, in the same way, almost all the graphical representation and the graphs are provided here. And we'll come to this most important section is the complexity matrix. Okay, see, this is the overall plan metric here. So 30 plan metrics. This is a jaw area. Okay, we'll define the jaw portions. Okay, okay, these are the uh, plan metrics, and below that there is a beam specific metrics also. Okay, the same MCS with the beam specific. So overall plan metrics, we already seen that the four different categories: the plan complexity, accuracy for dosimetric metrics, secondary metrics, and also a deliverability characteristics also defined here. Okay. And once if you are good with that, then we can able to export this complexity matrix as a CSV, Excel file, and the PDF file. I exported format I will show you in the end of the video. Okay. Once that is done, there is a batch file analysis. The next is that if you click on the batch file analysis, we can see I have selected a multiple plans. We can analyze all in a one go and compare those metrics in also the same way geometry, beam, complexity. And we can export in the three different formats: Excel, JSON, and PDF file. Okay, now moving on to that. Okay, hold on. In that one also, there is a preset mentions all mentioned here. We can change it if you want. These are the second most important one, the comparing the plans. So while the comparing the plans is pretty easy, just as the plan A is the reference one, plan B is for the which plan you want to compare with the reference. Just I'm adding the one plan with the reference and second plan with the for comparison. Okay, this is for the aperture safe control setting is off and this is kept as a very high. Okay, now there is no MLC data, which means that the field we selected is the APKV setup. Okay, for that we have to scroll down to the bottom and select the field as a clockwise. Now we come back here, we can able to see this. Okay, if you move this cursor over here, we can able to see how with the same control point 42, how the beam aperture of the plan A and plan B, which is very uniform, which is why it's because the controller aperture control setting is very high, uniform and MLC apertures as well. And here's the quite staggered and spiky small segments. Okay, in the same way we can able to evaluate the plan visually. But in the metric comparison, if you go to the left side, there is the same metrics from the total MU to how much change has happened from plan A to plan B. And the same matrix is that plan aperture area. Sorry, this is the plan modulation complexity, how it is like reduced. It is modulation complexity which is closer to zero, which means that higher the complexity. Closer to one is that relevance will have to get it from the technique, the help and documentation. We can able to see those interpretation, how we have to interpret this scope. That is completely a different approach. Okay, and the same goes for aperture area variability and all the metrics we can able to compare and we can able to see those values. Okay, and we can compare the delivery comparison for the aperture, how this plan A and plan B is exploring, and this is for the gantry, and this is for the complexity. And these are the MRC distribution by gantry angle. Now I selected the counterclockwise, that's why it's showing like this. Okay, in the same way we can see. That is all for the plan comparison. And we can able to export it in as a PDF format only. Fine. Now moving on to the statistical analysis. Okay, so for that we have to upload a multiple plans, not just one single plan, multiple plan of the same category. Which one you want to meaningful to analyze, right? Okay. So now it will give you a scatter plot, correlation matrix, and as a violin plot, depending upon the which metrics we have chosen here. Okay, we can change the metric as much as you want. Okay, with that we can able to change the plot and correlation matrix as well. And most importantly, the detailed statistics. Okay, these are the statistics. We can see how much range the overall plan of the score is ranging, and also mean and standard deviation. Okay, the same goes like all the statistics parameters are for almost 10 or 15 metrics are mentioned here. Okay, I have added only 7 plans. We can, if you add much more than that, it will give you a proper result. Okay, and yeah, these are the techniques we can able to change And here we can able to modify those metrics. Okay, once we selected, if you have to select uh, this one, geometrical value, and we can able to analyze those as well. And the geometrics will be given in a statistics. Okay, and yeah, and this plan analytics is the software is a local host, and it is available as an open source in the name of Plan Complexity Lens. I have modified some ideological difference and this changes some visualization. I'm locally using it as for my purpose, um, my analysis. Uh, okay, it is available in the GitHub in the name of RT Complexity Lens. Okay. Uh, uh, Any questions, ask me in the comment. That's all for now. Thank you.